Hi everyone, welcome to today's lecture. So today we're looking at sets of numbers, and under sets of numbers we'll first look at the types of numbers. Then apart from the types of numbers, we'll also have to look at rational numbers in details. Then from there we'll come and proceed with lecture 4, which is going to have irrational numbers. Okay, so let's quickly begin. So we'll start by looking at what even numbers are. So even numbers are simply just even numbers are simply just numbers that end with 0, 2, 4, 6 and 8. So any number that ends with 0, 2, 4, 6 and 8 is called an even number, meaning that number can be divided by 2 and the remainder will be 0. So any number that can be divided by 2 and leaving a remainder 0 is called an even number. So that's how you define an even number. So from there we look at odd numbers. So odd numbers are just numbers that cannot be divided by 2. So when you divide these numbers by 2, you have to leave a remainder 1. Yeah, so when these numbers called odd numbers are divided by 2, they leave a remainder 1. Examples are 1, 3, 5, 7, 9. Yeah, so those are odd numbers. Yeah, so some of them define odd numbers as numbers that end with 1, 3, 5, 7 and 9. Okay, so let's quickly look at what complex numbers are. So we're just looking at types of numbers. So complex numbers are simply just numbers that can be written in the form a plus bi. So a plus bi, where these are represented by z. So a plus bi, a and b are real numbers. So these are this is I, not j. So I, a plus, but in some books they use j. So this expression should contain y, and then this it should contain I, and then this I satisfies it's an indeterminate that satisfies the condition I squared is equal to -1. So the reason why I squared is equal to -1, I itself is just equal to the square root of -1. So if we say I squared is simply just the square root of -1 and then squared. So this square and that square root cancels, so meaning you just have I squared is equal to -1. So that is a complex number. It's simply an imaginary number. Okay. So we also have prime numbers. So prime numbers are simply just numbers with only two factors, 1 and itself. So these are just numbers which only have two numbers that can go into them, meaning they only have two factors, that's all, which is just 1 and itself. Okay, so examples of prime numbers are simply 2, 3, 5, 7 going up. Right, so I'm just doing it very fast. I'm just doing it very quick. Okay, so we have also what are called natural numbers. So natural numbers are also called positive integers. These are just counting numbers, and these are just counting numbers starting from 1 going up. So natural numbers are just called positive, they are also called positive integers. They are counting numbers starting from 1 going up. Yeah, so examples are 1, 2, 3, 4, 5 going up. And then we have whole numbers. So whole numbers is simply, whole numbers, this is just a set of natural numbers, but to this set of natural numbers you just add a 0. So when you just add a 0, when you're counting and then you start from 0 going up, it means that you are talking about whole numbers. From there we can look at integers. So integers are simply just all numbers plus all those negative. So it's just a set of positive and negative whole numbers. In short, when you add the positive whole numbers and you also add negatives on in front of the whole numbers, you get a set that is called the set of integers. Yeah, so sets of integers can also be in the real, can also be written on the real line or on the number line. So okay, depends. If we say a real line, it means that you are also counting together the real numbers, you're also adding real numbers. So integers are simply real numbers with positive and negative signs. Yeah. So we look at rational numbers. So rational numbers are simply just numbers that can be expressed in the form a over b, and then a and b should be members of integers, and then a and b should be members of integers, and b should never be equal to 0. Then this a and b should be co-prime factors. Co-prime factors. So they should be co-prime factors, meaning a and b, or rather this fraction is in its lowest term. That's what it means. So rational numbers are simply numbers that can be expressed in the form a over b. So today we're going to go in details about rational numbers, and then tomorrow, the next time we meet, we'll do irrational numbers. So irrational numbers are simply just the opposite of rational numbers. So when you say the opposite of rational numbers, we mean since we said rational numbers can be expressed in the form a over b, meaning irrational numbers cannot be expressed in the form a over b. Now, which numbers are these irrational numbers? These are pi. We know that pi, when this is just 3.142, then the numbers keep on going like that. And then you also have numbers like the square root of 2, the square root of 3, the square root of 5. These are all irrational numbers. Okay, so let us also look at the set of real numbers. So the set of real numbers is simply just a set that is just found by adding rational and irrational numbers. So when you add rational numbers, and irrational numbers, when you add rational and irrational numbers, the answer that you get is simply just a set of real numbers. So rational numbers and irrational numbers will give you a set of real numbers. Okay, so let's look at examples of these real numbers. So we have real numbers that are terminating and repeating. So we have this one. This is a real number, and to be specific, this is a rational number. This is a rational number that is terminating. This one is also a rational number because it can be expressed in the form a over b, which is 1 over 2. Even this one, 10, can also be written as 10 over 1. It's a fraction. So that is a rational number. Then when you talk about pi is an irrational number, but it's also part of the set of real numbers, because we said real numbers are simply just a combination of rational numbers and irrational numbers. Okay, so some real numbers have decimal parts which repeat. So for instance, you have these are just real numbers which repeat. These are real numbers. We've seen that 1, 2 are repeating. So when you say 1, 2, 1, 2, 1, 2, 1 and 2 are repeating, so you just put a bar on top there on 1 and 2 to show that 1 and 2 are repeating. So we also have this one here, which is 3.1455555. The 5s keep on repeating, so we have a bar on 5. So let's now look at rational numbers in details. We have rational numbers that repeat. Repeating rational numbers, these are the examples that I even gave on the previous slide. And then we have terminating rational numbers, which are just fractions that we already know, which can be 2 over 5, 1 over 2, 1 over 3. These numbers are terminating. So these numbers are terminating. So for instance, this one here, 1 over 2 is simply just 0.5. These are terminating, or they terminate in short, they have an ending. Okay, let's look at this example here, these examples. In the following problems, find the form a over b of the given decimal expression. find the form A over B. So in other words, they are asking us to express these into these numbers into a fraction form, these numbers into a fraction form. So how do you do that? This one is straightforward. First of all, you have to equate this to x. So you can either say let x or y. So you use any variable of your choice. You can say let x be equal to 3.2 bar. So 3.2 bar, that's x. Then from there we can move this point to cover the repeating number here. So if we have any number in front there, would have started first by moving this point to closer to the repeating numbers, but in this case we don't have any number in front of the repeating number, so we just move this point to cover the repeating numbers. So how many steps are we moving? We're moving one step. So if we're moving one step, it's just the same as multiplying by 10. If we're moving 2 steps, it's just the same as multiplying the whole equation by 100. 3 steps, multiplying the whole equation by 1000. 4 steps is just the same as multiplying the equation by 10,000. So in this case, we're moving one step. Hence, it's just the same as multiplying this equation by 10. So when we multiply 10 times x there, we're getting 10x, and then is equal to, then we have 3.2 bar times 10, we're going to have 32 point, this 2 is repeating, so it will still be there, 0.2 bar. And then from there we can subtract this equation, we can subtract this equation from this equation. So we say 10x minus x, we're going to have 10x minus x is equal to, then we have this minus that, which is just 32.2 bar minus 3.2 bar. So from there, 10x minus x gives 9x is equal to 32.2 bar minus 3.2 bar. This is just giving us 29. How did I find that? So 32.2 bar minus 3.2 bar, we subtract this, we have this 2 bar minus 2 bar, we get a 0 there. 2 minus 3 is just the same as 12 minus 3, which is 9. We are remaining with 2 here. 2 minus 0 is 2, so we get 29. So 29, we have 29 there. So we can divide everything by 9, the value of x becomes 29 over 9. So this is how you do the, let me just go back to the slide. Okay, alright, so we have that. So 29, x is equal to 29 over 9. That's the solution. Let's move on to the next one. Okay, so the next one we do the same. We say let x be equal to 3.12. So here we have 1 and 2 repeating. So we have two numbers which are repeating. So this is just the same as multiplying everything by 100. So 100 times x gives us 100x is equal to 100 times 3.12 gives us 312.12 bar. So from there we can now have subtract. So 100x minus x, we have 100x minus x is equal to 312.12 bar minus 3.12 bar. So when you subtract this, you are going to have 99x. 100 minus x is just the same. 100x minus x gives us 99x. Then this other side we get 312 minus so we get 309. So 309, to find the value of x, we divide everything by 99. So we'll have something like this. Okay, let me just erase this. Okay, so we have, let me just write everything this side. So we have 99x is equal to 309, and then we divide by 99. So this is a 0 here. So we can simplify this to 3 into 3, 1, 3 into 0, 0, 3 into 1, 0, 3 over 33. 3 into 9, 3 into 9 gives us 33. So that is the answer. Let's move on to the last one. So the last one is simply just so we say let x be equal to 3.34. So 3.34, that's x. So we can now say we move this decimal point to cover the repeating numbers, so meaning this will just be the same as multiplying by 100. So 100 times x, we get 100x is equal to 100 times 3.34, we get 334.34. 34 is repeating, so that's what you do. So from there, 100x minus x, we get so this will be equal to, then this yeah, so 334 minus that, we get 331. Sorry, let me just write 334.34 bar minus 3.34, yeah, for the sake of understanding. So when you subtract 100x minus x, we get 99x is equal to, when you subtract 334.34, so that's the same as having 334.34 bar and then minus 3.34 bar. So we have this minus this gives us 0.4 minus 3 gives us 1, then we have 3, we have 3, so 331, so we have over 99 over 99. So the value of x becomes 331 over 99. Yeah, so the answer is simply just 331 over 99. We don't have any number that can go into these numbers, hence we leave it like that. So let's quickly look at the other questions. Okay, so let's look at this. We have the first one there, so I'll skip this one because it's similar to the ones that I'm from solving. I'll move on to this one and the rest. So if you want to see the solution for this, I'm going to send the link in the group where I've solved all these questions. So we have 3.3 bar. Okay, I'm not going to solve. Anyway, let me just solve it. Okay, anyway, let me just solve it for the sake of revision. Okay, so we say let x be equal to 3.3 bar. So we move this point to cover the repeating number there, which is just the same as multiplying by 10 since the repeating number is 1 there. So 10 times x, we get 10x is equal to, then 10 times 3.3 bar is just 33.3 bar. So from there we can subtract 10x minus x, this minus that, then we have 33 is equal to 33.3 bar minus 3.3 bar. So 10x minus x gives us 9x is equal to 33.3 bar minus 3 bar is just the same as 30.0. So we divide everything by 9, the value of x gives us 30. We have to reduce this to its lowest term. 3 into 30 gives us 10, 3 into 9 gives us 3. So this is the answer. So we quickly move on to the next one. So the next one is simply just, so we can say let x be equal to 2.13 bar. So we can move this point. This time there's a number before the repeating number, so we move this point closer to the repeating number. That's the first step. So we're going to say we're going to multiply this by 10 so that that point moves to the closer to the repeating number. So 10 times x, we're going to have 10x this side is equal to 10 times this number, we'll have 21.3 bar. So the next step is to move this point to cover the repeating number, which will be 1. So it's just the same as again multiplying by 10, this same equation. So 10 times 10 there, we get 100x is equal to, then we have 10 times 21.3 bar, we have 213.3 bar. Then we can subtract, so we have 100x minus 10x. So we subtract this equation from this equation there. So we have 100x minus 10x is equal to, we have 213.3 bar minus 21.3 bar. So 100x minus 10x will give us 90. X is equal to, then when you subtract 213.3 bar minus 21, the answer will just be 192. So the answer will just be 192. So 192. So we can divide by 90 this side, divide by 90 this side. So the value of x becomes so when you reduce this, by dividing it by 6, yeah, so you divide this by 6, you find that on top there you have 32, and then down here you have 15. So this is what you are going to have when you divide it by 6. Alright, so that's the answer. Let's quickly move on to the next question. Okay. Okay, let's quickly move on to the next question. Alright. Let me just erase quickly. Okay. Alright, so the next question is this one. Oh, sorry, this one. So we also do the same. We say let x be equal to 3.312, and then 1 2 is repeating. So from there we move the point closer to the repeating number. So we move one step, we come here closer to the repeating numbers there. So it's just the same as multiplying by 10. So 10 times x, we get 10x is equal to, and then 10 times that we get 33.12 bar. So from there we can now move this point to cover the repeating number. So move how many steps? 1 2. So this is just the same as multiplying by 100. So 100 times 10 we get 1000 x, and then this will be equal to 100 times that we get 3. So we get 3312.12 bar. So we can subtract 1000 x minus 10x is equal to, then you subtract this 3312 minus 33. So you're going to have 3312.12 minus 33.12 bar. So when you subtract this side, you're going to have 990x is equal to, then on this other side we can just do it together. Here we have 3312.12 bar, then 33.12 bar. So 12 bar minus 12 bar, this will give us 0 0, then 2 minus 2 0, 1 minus 1 0. Then here 2 minus 3 we get 1 from there, 12 minus 3 we get 9, and then this is 10 minus 3 we get 7, and then this is 2 there, then we have 3. So 3279 we get 3279 279. So we divide everything by 990, even here 990. So from there we can now find the value of x by reducing that to its lowest term, which will just simply be x is equal to, so when you reduce this to its lowest term by dividing everything by 3, you discover that your answer will just be when you divide 3 into 3 there, you get 1, and then into into 2 you get 0, 3 into 27 you get 9, 3 into 9 you get 3, then everything divided by 3 into 9 3, 3 into 9 3, 3 into 0 0. So this is what you are going to get as your answer. Alright, so the same way I've done this, that's exactly the same way you do the last question. So the last question, so on the last question we have 3 repeating numbers. Okay, you have 3 repeating numbers on the last question. Yeah, so you have 3 repeating numbers, which is just the same. You do it in the same way I've done this one. Let's quickly do it together. Okay, so you say let x be equal to 5.123. So you cover the repeating numbers there. It's just the same as multiplying by 1000, since the repeating numbers are 3. So we multiply by 1000. 1000 times x, you get 1000. X is equal to 1000 times that, you get 5123.123 bar. So you can subtract 1000x minus so you can subtract 1000x minus 1000x minus x. So we say 1000x minus x is equal to, we have 5123.123 bar. And then you also have minus 5.123 bar. So subtracting these two numbers, so 1000 minus x you get 999. X is equal to, when you subtract 5123.123 minus 5.123, the answer you get will simply just be, because you're just subtracting 5 from this number, so you just get something like 5118. So from there you can divide everything by 999 over 999 to get the value of x. So x becomes so the value of x becomes, when you simplify this, you divide everything by 3, you divide the numerator and the denominator by 3, so you get, on top there you get 1706, and then down there you get 333. So this is what you get as your answer. This is exactly how you find your answers when you've been given such questions. So thank you very much for watching today's today's lecture. Let's meet in the next lecture, which is going to be on irrational numbers. Thank you very much. See you in the next lecture. Shalom, shalom. I'll send an exercise at the end of this.